My name is Alex Weinert. I am the Group Program Manager for the Identity Security and Protection team at Microsoft. Collectively, we're responsible for protecting about 4.7 billion accounts in every country where it's legal to do business, in every sector and every kind of imaginable scenario. We're the team that protects Xbox and Skype and Office and you, probably. If you're an Office 365 or Azure Active Directory person, stick your hand up. All right. Yes, awesome, thank you. So what we're gonna do today is a little bit different. We're gonna take you through a couple of scenarios. We are, as a team, we actually kind of have divided responsibilities. One thing that we do is actually response and mitigation for accounts that get taken over or attacked. So we will get involved. I sort of joke that if you don't have nukes, you have to wait, but we'll get involved in major compromised situations with our tenants and try to help on that side. And then we take whatever we learn from that and we wrap it up into our detection systems. And then all that goes into power, in part, conditional access. So our team is responsible for identity protection, conditional access, and multi-factor authentication, as well as doing a lot of response. And Nitika is on my team. I'll let her introduce herself.
Yeah. Hi, folks. My name is Nitika Gupta. I'm a program manager on Alex's team. I focus specifically on the security experiences for identity protection, conditional access, and multi-factor authentication. Looking forward to this talk.
Right on.
Yeah.
All right, so we'll dive in. You know, one of the things that we would love to drive home is that it really is a new world order. The network you set up 20 years ago, you know, with the assumption that if somebody had access to the network, they must be on the corporate network in the building from a machine you own. That's gone, right? They're not accessing servers you manage anymore. All of that stuff is gone. There's a mistake, I think, that people make, which is punch a hole into your network with a VPN and then assume that things are safe there. So now with a username and a password using an old protocol like Radius, I get access to your corporate network and all the assumptions you made over 20 years about safety, right? And it turns out not to be the best possible model. We're in a new world where the devices are owned by your users, right? And they're traveling, that the network is, I don't know, MSFT Wi-Fi right here, right? And you're accessing a service that has your mail on it or documents on it that your company doesn't run any of the infrastructure for. And the only thing that remains in that world to kind of use as a way to, you know, to bring order over that and get all the productivity value out of that is your identity, right? So that we say identity is the new control plane, and we're gonna talk about how that factors in on a security level. You know, we are happy to see traction with companies all over the world in every sector getting benefits out of this and also getting security benefits out of it. And so we'll talk about that. If you saw Alex Simons is my boss. I'm the other Alex, later in the alphabet, Alex W. If you saw Alex Simons talk earlier, he talked about all the different things Azure Active Directory can do. We're gonna focus on the stuff in this right column, things like conditional access, multi-factor auth, identity security reports. We'll talk a little bit about PIM. The main engine that drives the work we're gonna talk about today is conditional access. Conditional access allows us to take various elements of the login, like who the user is, what device they're on, is that device compliant, what's the location they're coming in from, what application are they trying to get to, and apply all of that together to do a couple of things. One of the things that's interesting is that we process, and 10 terabytes is the number we say publicly. The actual number is much closer to 40 now. 40 terabytes of data a day through our machine learning systems. And what we're looking for is what's normal, and then where is the drift from normal in the logins that are happening. And all of that allows us to assign a risk score to the session, right? So with every login, we can kind of do a predictive analysis of what the risk is. And then that becomes another thing you can put conditional access policy around. And so those policies then go into allowing you to set up what you want to have happen next. Multi-factor auth being one of the big ones for risk. Then you know, you can do other things as well, and we'll talk about some extensibility and some ways that we've opened that up today to other folks in the multi-factor auth world. I do this slide, you know, every so often, and I have to increase the numbers every time. It just gets worse. The one number here that's getting better is that the time that is resident on network is coming down. So we're down to only 140 days, right? So, you know, it's a much better situation. The bad guy only has control of your domain for like 4 months. Now that's better than the 9 months it was a year ago. And that's because of technologies like advanced threat analytics that are letting us see better inside the network. There's an old statement in security, you know, like if you work with like police, you know, you'd say which house is safer, the house with the blinds up and the lights on, or the house with the blinds down and the lights off? And the house with the blinds down and the lights off is actually a much more attractive target to a criminal because I can work inside that place and do my damage and not be seen. And the old sort of VPN in, get access to the network and, you know, work around, that's the same kind of world. So you better have some lights on if you're gonna run that kind of network. One of the things that really differentiates us is we call it the intelligent security graph. I am sure you have heard the term at some other talk at this conference, but basically we have a very high amount of signal. We process 14 billion login events a day. We have a very strong sense of what normal looks like and therefore what abnormal looks like in the environment. Bad guys can do a pretty reasonable job of trying to emulate, you know, normal up to some degree, right? You get phished, you come in from an IP address, they may come in from a nearby IP address. But the very large amount of signal we have allows us to get a very refined sense of what normal is. And then you augment that with things like the information we get from the digital crimes unit, on BetNets, and on, you know, like our Cyber Defense Operations Center for the attacks and the Microsoft Security Response Center, as well as industry partners like Google, as well as governments that like send us information. And so there's a huge amount of data that we're working with, and that's a really major advantage for us in this war. And what it does for us is it gives us the ability to do lots of good detection, right? We're very good at detecting when bad things are happening. The issue here is whether you're responding to the bad thing, right? So for example, we send out security reports, but many people aren't aware of them. We're gonna change that today. We have the ability to set policies so that when you do a login, you challenge the login with MFA if there's risk. People who aren't aware of that, hopefully will be aware of it by the end of today. And so we're gonna go through on an attack by attack basis and teach you how to do this. When we look at this huge volume of attacks, there's a common element. I bet you can't guess what it is. Okay, I made it easy, right? The common element in all these attacks is gonna be passwords. So we have this, you know, thing that we've been doing since, I guess, May, like death to passwords, right? Like we wanna see, our goal is to see 1 billion accounts not logging in with passwords in 12 months, right? That's what we're gonna try to do. We're gonna try to get essentially 1/4 of our user base off of the daily login with password. If you look at things like Windows Hello, right, when I logged into this machine just now, I opened my laptop, it saw me, did a biometric print, I used that to unlock a PKI, a key pair on the TPM, and then sent a nonce up to the cloud. So the only thing that is stored in the cloud is a public key, right? The rest of it is secure in hardware. I don't have to remember a password. And it's a very easy login experience. That's an example of how we can move to the next level on this stuff, right? And we're doing work with the FIDO Alliance to, you know, embrace those kind of tokens. We're doing other things like through our push notifications app, and we call it internally NOPA. The main dude on NOPA is right there, that's my friend Dennis. And the goal here is to get us off of passwords. But guess what? Who here has passwords in their environment? Yeah, everybody, right? Okay, if you didn't raise your hand, you're probably checking your email. I'll try to be more entertaining. But you know, we have this problem, right? Like we have to accept that there's a tail. So while there's that tail, we're gonna talk to you about how we get you into a more secure state. The bottom line is, and you'll understand it deeply by the end of this talk, your passwords are okay occasionally, but very often not okay. And you have to have something that can backstop your passwords. And so the first thing we're gonna talk about before we can set up the rest of the talk is that you have to have a multi-factor authentication solution in play. On our consumer side, we had like 1.8 billion accounts that were in various states of multi-factor authentication readiness. And about 3 years ago, we adopted the strictest stance in the industry in consumer, and we said every single one of those accounts must register a second factor. The results were staggering for us. You know, we saw unaided password reset recovery go from 16% to 97%. You know, the amount of money we saved was staggering. We drove down compromise in the system because we're free to challenge more, right? We can actually say, oh, look, something looks weird, let's just do that MFA because we know you can handle it. Get your users into a state where they can handle it. We're gonna start with that, and Nita's gonna take us through a quick view of that. And you're going to 8.
Please switch. So before we can start protecting our organization with multi-factor authentication, you first need to make sure your users are registered. As Alex mentioned, we did this on the consumer side. We enforced this policy where we made sure all our consumer users have multi-factor authentication set up for their account. But on the enterprise side, we can just provide you a policy. We can't go enable it for you. So we need your help so we can protect you. So here I am in the Azure portal. This is the Identity Protection console. Have you guys seen it before? We'll talk more about it as we go through this presentation. You can simply go to the MFA registration experience here, assign the policy to users and groups, and here we really suggest you to start rolling out with a small group of users and slowly get to all users. We also have an option to exclude users from the policy. So here you can say, I have some folks who are traveling who don't have phone on them, so I can exclude them from the policy for the time being. So you can simply include the users you want, exclude the users you want, and then save the policy. We have pre-selected the control for you because we know you want to do MFA registration. With that, Alex is going to show us the end user experience for this.
All right. So far all I've done is I've typed office.com and I'm signing in. This is our new sign-in experience, which I like a lot. So we're going to start with this first flow, which is just entering the username. So I'm going to go ahead and enter my username here and do my password. Which hopefully I'll remember correctly. All right, and you see that the next page, this interstitial says, look, for added security, we need to further verify your account. So this is the experience your user gets. We have done this for several billion people in our consumer space, several hundreds of millions of people in our enterprise space. I know that everybody is nervous, but they can handle it. They're doing it for their Google accounts, their Facebook accounts, for their Microsoft accounts. You know, they can handle it for your account too. And what we're going to do is just say, set it up now. Okay, and in this case, we've selected the mobile app. There's a reason for this. The mobile application, I believe, is our best option right now. If I were to say, you know, everybody pull out your smartphone, right now, pretty much 100% of you guys could do it. In most markets, most places I go, people have the smartphone. There's an application on there, the Microsoft Authenticator you can get, and it does a push. Now, this is not the same as doing an SMS, which I'll also demonstrate. The push notification is easier to use. It has demonstrably better usability. It's also much more secure because we can encrypt what's on that wire. It's also more accessible because it works anywhere there's Wi-Fi, right? And so you don't have to rely on getting an SMS signal. So I can, for example, approve a notification in the plane, you know, on the way back to Seattle tomorrow, right? So as much as I'll miss you, I am going to go see my family. So what we're going to do here is we're going to say set this up. Okay, and the experience you see is I have this screen. Now, I have not ever done something as cool as this before, but apparently, now you can see my phone. Woohoo! All right, and what I can do is go through here and just say I'm going to add a new work account. Okay, and it grabs the code, and then at that point, I'm going to be able to go through and just have registered on that device, okay? So from here, I'm going to say next on the screen. We're going to do some screen dancing. And then the app is going to go ahead and run a code through my phone just to make sure I understand how to use it. And so that's sort of the training phase of this. And I realize the words are small. But what we're seeing is basically, hey, let's make sure we can do that thing. Okay, so going back to my phone, I get this notification. It says, do you want to approve the sign-in? I say approve. Okay, and I'm registered, like I'm done. Okay? At this point, I have multi-factor authentication registered. I demoed it in, I don't know, what was that, 3 minutes? Again, we find that the usability here is good. Of course, we want to do better, and we're always looking for ways to optimize the experience, but your users can handle being MFA registered. If you're not registering your users for multi-factor auth, we should fix that. Okay, now that that's done, we can get back into our flow. So now the ugly stuff starts. All right, let's talk about attack type 1. Password spray. You know Mad-Eye Moody in like Harry Potter? I feel like that dude sometimes. I'm like, ah! Anyway, so password spray, it's going on. We're getting huge numbers of password spray attacks. We saw 45,000 enterprise accounts fall to password spray in August. Enterprise AAD accounts, 45,000 of them. They all fell for the same reason. Because your passwords stink. That's why. In a population of 100 users, if I do a password spray attack against your organization, who here's got an organization greater than 100 users? All right.
Everybody.
I get one of your accounts, guaranteed. 1% of accounts are going to fall to password spray attack if you're not using some kind of mitigation. Okay? If you look at the graph on the bottom here, I'll try to show you what's going on. The bright color bars that are all pretty, those are all bad. If on the right-hand side of the screen, that's normal state, that's no attack. And what you're seeing there is that's a count of the top 10 hashes for passwords in that hour. All of the top 10 password hashes together should essentially not register on the graph. And then what you see, if you go back a few hours, you see these bright color bars. And there's one here that's like this orange one towards the end. It's 4 bars. Well, those 4 bars are each about 80,000 accounts in 1 hour. So for 4 hours, 80,000 accounts an hour were tried from this attacker with the exact same password. Right? So what's going on? Well, they're sitting on a list of 320,000 accounts that they pulled off of Yahoo's breach or, I don't know, pick one. They're happening all the time. Right? They're pulling from these accounts, they're running through them, and then they say, okay, let's try password 123 on every one of those accounts, right? And as they get through that list, they're gonna pull some number of these accounts out, and then they're gonna roll to the next password and try it again for any account that didn't fall on the first pass, and they're gonna try it again until it gets stopped, right? So as we look at that, is that gonna trigger password lockout? No way, because it's like 6 hours between account usage, right? And so what's happening here is this is the way they're doing these attacks, and they capture a lot. Like I say, 45,000 accounts went down this way last month, all because they had lame passwords, right? Lame defined as didn't work very well, right? Pretty easy to guess. Okay, so this is how the game is played. The passwords on the right, because we see these attacks, we can actually generate a histogram of the most commonly used passwords. And when we do that, we can then push that into what we call dynamic band password system, which is owned by that dude right there. And what happens is we're able to say, let's take the password that you're trying, check it against that list, check it with the normal substitutions. You're not the first person to think of using an @ sign instead of an A, right? So we're gonna check it against the normalized version of that, check it for substrings, check it for deviations, and then only if it doesn't match anything on the list do we allow it to go through, right? By doing this over the last 4 years in Microsoft account, we've essentially killed the password spray attack. Because no password in the last 4 years that's been set in our consumer system has allowed a commonly used password. But for you to do this requires a little bit of work. We'll show you what you need to do. It's seriously check a box. So if you think your attackers are all like super genius dudes that are like, they have multiple screens, no, they just buy a tool like this for like 70 bucks, right? And what this tool does is you feed it a list of accounts and it'll go do the rest of the work for you. Okay, these tools can be more advanced. They can go out and spray through botnets. They can go through proxies to anonymize or Tor. There's lots of ways they can work, but it's really, really straightforward. So our attackers don't have to be geniuses. They collect up these accounts. So what do we do to mitigate it? Well, guess what? Your password complexity rule is awful. It's not just not helping, it's hurting you. And the reason is that if I tell each of you a rule that's complex for passwords, 2 things happen. The first is you will react predictably to the rule. Right? If I tell you need an uppercase, a lowercase, and some numbers, I know how you're gonna do your password, right? And the second thing is that if you're a crypto nerd, right, key space matters. And when you put a bunch of rules on a password, you're limiting the key space. So you're making it easier and easier to guess these things, right? Because I can read your password rules just as easy as your user can, and then I can only generate passwords that match those rules. And so you're making it easier and easier for me. Okay, but what about expiration? Expiration's cool, right? Except for the fact that when a password falls, it's used within minutes, not days, not hours, not months. So the password change didn't help you. And guess what? You just made it harder for your users, so they're gonna pick an easier password. And then, wait, time-based? I have to change it every quarter? I know, I'm the only one who ever thought of this. I'm gonna call my password fall 2017, exclamation mark. Oh, wait, @ sign for the A. That's the killer. Okay, so now I have the unguessable password that like every hacker can guess, right? And so don't do password expiration. It's a bad policy. It's measurably, backed up with research, bad policy. Okay, the third thing that's not gonna help you is really long passwords. Up to some reasonable length, you wanna have some length because you're gonna wanna make sure that the rainbow table attacks and dictionary attacks takes a little bit of time, right? The brute force, hash breaking if there's ever a breach. But generally speaking, what you get is people who are super clever and they're gonna do fall 2017, fall 2017. They just duplicate the word, right? And so you just keep trying to make it, or better yet, my password is awesome, so I put it on my keyboard, right? So these things, or put them in a Word doc, right? We've seen that. We've seen teams share their complex passwords on SharePoint sites in Word docs unencrypted. And guess what happens when the bad guy gets in with one account? Oh, thank you, I have all of them now, right? Okay, so NIST updated their guidelines along the same lines. It's actually good guidance. So the one thing that they say to do is validate passwords against commonly attacked passwords. Okay, so we hate bad rules. Bad rules make good people do bad things. We do have good guidance. I really want to, you have this deck you can look at on the site. It's aka.ms/password guidance. Check out that paper if you want to go deep on this stuff. Otherwise, just take my word for it. Turn off your complexity rules. Turn off your expiration rules. In the meantime, turn on banned password support. We're going to show you how to do that. And then also turn on attack detection and account marking for this stuff. So once again, Nitik is going to take us through and show us what to do.
So Alex talked about how password policies are bad and how there are dynamic banned passwords that you should be blocking. So one way to achieve that is to make sure you master your passwords in Azure Active Directory. So Azure Active Directory can take care of all the dynamic banning of passwords. You don't have to worry about it on premises. So for a hybrid customer, what that means is you got to enable password write back for your environment. It's as simple as checking a box. Like really, if you're using the Azure AD Connect wizard, just check that box which says password write back as one of the optional features and you're good to go. That's one piece of configuration you got to do. On top of that, let's switch it up.
All right.
On top of that, the second piece of configuration you need to make sure you master your passwords in cloud is enabling password reset for your organization. And again, super simple. You go to the Azure portal. I'm in the directory experience, and I selected password reset. Within password reset, the first thing you see is, hey, who do you want to enable password reset for? So I simply selected all. That way, all my users have the option to reset password, both for password spray as well as for reducing my help desk cost. So with that, Alex will show us what happens to his account when he tries to reset his password.
All right. It's been a long time since the first demo, and I've kind of spaced out what my password was. Because I'm doing my logins in the cloud, right, I can go ahead and just say I forgot my password. So this is back to the Alex one at Wingtip Toys, the same account as before. I'm just going to say I forgot my password. All right. We get to do the mandatory CAPTCHA. We want to keep some of the machines at bay. All right, and so I said we would demonstrate a second method. This is text, and again, believe me, text and password is far better than password alone. You guys can all call me, you have my digits now. All right, and I've got my code. I'm going to trust you know what a text message looks like, so we're not going to show that on screen. All right. Okay, then from here I get into my password change screen. So what's happened so far, right? We forgot our password, we're just doing a password reset. Number one cost driver for IT help desk, right? 60% of your users forget their passwords. Those who forget them, 70% of those will forget them twice a year, right? The numbers are pretty high. So having automated password reset is a huge value in terms of cost drivers. But one of the nice things it does for us, it also allows us to inject our dynamic banned password checking, right? So if we were to go back, I'm going to go live without a net. We're going to see who's brave here. I'm going back a few slides. All right, somebody not from Microsoft can call out a number here on the right from our common list, 1 to 25.
Which one?
18, all right. Oh, that's not going to hit our requirement. You're going to have to go for a longer bad one. 22. I love you too, man. All right. So I just cut and paste. It's weak. It is weak. All right, so the error I'm getting down here is we've seen, I'm going to try to make this bigger for y'all. We've seen that password too many times before. Choose something that's harder to guess, right? And you'll get that if you substring it. You'll get that if you get smart and put in like an @ sign, whatever, until you come up with something that is actually distributed in the key space, right? And using this again, we've been doing this on Microsoft account for about 4 years, and it has effectively defeated the password spray attack. So I want you to look hard at doing what Nitika just showed you how to do. Super simple. All right, so we'll dive back into our presentation here. All right. So the next major attack we're going to talk about is breach replay. If you thought the numbers were bad from password spray, wait till you see these numbers. All right, 12 million accounts per day are attacked through breach replay attacks, per day. The actual number of attacks can kick up towards 300 million a day. So same account will be attacked repeatedly. And so this is for people who have the lists and they're playing them back against us. The way they get the list, like Yahoo, 1.5 billion accounts breached. Anthem, 87 million accounts breached. Right? We're going to talk a little bit about Ashley Madison, 37 million accounts breached. The match rate we see on this is about 284,000 a day, and we will mark 31,000 accounts every day compromised from breach replay attacks. Okay? If you just watch the news, you'll see they come into the market in the tens of millions, and somebody's going to get them and try to launder them. So we'll talk through this here real quick. And then we also have another feature around when we get handed lists, either find them on the black market or our researchers find them or they're given to us by governments, and we can do list discovery processing. That gets us about 1.2 million in this month. Only 266 accounts fell this month to that, but the numbers are still important and often admin accounts. Also, that is highly stochastic, which is to say there will be months that are very, very high numbers and others that are fairly dormant. I know you're going to say, but my users, I had, with a straight face, I had a CSO say this to me a week ago. My users don't reuse their usernames and passwords. Like, of course they don't, right? Okay, please, I'm not going to ask somebody to raise their hands. Don't believe that, okay? And here's my evidence for you. Ashley Madison, like look at the accounts that were in the Ashley Madison breach, right? Church accounts, government accounts, education accounts, right? If there was ever a situation where you're like, I probably shouldn't reuse my work account, right? That was the situation, and yet, right? So yes, your users do reuse their usernames and passwords on other sites, as a matter of fact. And once again, when they do, when I scrape those things up from various breaches, the ability to go and check and see, is that also valid on another site, is trivial. The toolkits are very, very simple. So this is an account checker. I feed it a CSV file, username and passwords, right, of however many I have. I say check accounts, and it spits out a list of categorized files. Isn't that nice? So there's a bunch of files that are broken out. These ones work, these ones don't work. These ones are, suspended and ejected. This one's against our system, against Outlook, but it's no different to run it against any other system, okay? And once I've got them categorized, I can put them up for sale. Now, we have all kinds of super researcher dudes that go out and like research the black market, but I took 10 minutes in my room this morning and a Tor browser, and I went out and found this site, buyaccounts.com, buyaccs.com. I would recommend you don't give them your money, just because it's not, don't encourage the behavior. But if you were to drill into this, you would see that there's things like, Gmail PVA, which means phone verified account, right? So these are accounts that are really good, like usable accounts. And if you go down the list far enough, you'll start finding things that maybe have your company's name in them, right? And so you have to, be aware that there's a whole ecosystem out there that's running to go do these things. All right, so what do we do? Well, we're really good at detecting these spray attacks. And the advantage we have at running a consumer ecosystem is that when the bad guys get these lists, one of the first things they do is they try it against any site that would accept any username, right? So I'm gonna go try it against Twitter. I'm gonna go try it against Facebook. I'm gonna try it against Google. And yeah, I'm gonna try it against Xbox, right? And the reason I do that in part is because, of course, those accounts have value, but also because if you're a reuser of usernames and passwords, you probably do it in multiple places. So it's a higher and higher probability that that thing I found will also match on the corporate side, where there's some real money to be had. So these are the numbers for August. Those are the real deal. You will see that around the 3rd of August, we peaked out at 310 million account breach attempts using reused passwords and usernames on a single day, okay? Around 14 million users a day, All right, so busy month. All of that telemetry is gathered and processed by our machine learning system, so we are watching what they're doing and we're pumping it right back into the system to stop these attacks. So our efficacy gets better and better. What we do is we lie to the bad guy. Hey, yeah, sorry, wrong password, right? But we remember what we saw and then we try it with the good guy, and if it works, then we know we have a problem. Then we'll tell the good guy, that's you. And then 12 million accounts a day, again, tried, and fairly low rate of penetration at 0.26% with correct creds, but still 1,000 accounts, right? 2 of them fall. All right, in the wild, there are a bunch of different ways that we can get lists, right? There are people who will they'll steal 1 million accounts, they'll put up 20,000 on a paste bin and say, hey, check it out, these are valid. Right? They'll try to sell them to us. They'll try to sell them to researchers. They'll have them on a hard drive that's captured by the FBI, whatever, right? We'll get those lists in a variety of different ways, and we process those through a credential processing system. And if you look at what we did, we processed so far this year 2.4 billion credential pairs through that system, okay? And in the enterprise, we have a fairly low match rate, but again, if you have 10,000 users or more, guaranteed to lose 2. Right? And so, the new detection rate here is significant. And so we're going to talk about what to do about breach now. And the main things here is, if we don't know what your password hash is, we can't do the comparisons and we can't help you, right? And the second thing is, if we detect that a user has been compromised and you don't have a policy to do something about it, we can't help you. So we're going to show you now what to do.
Awesome. It's a scary world out there. So how do you protect against breach replay attacks? The first thing that you need to do as an organization is make sure that your password hashes are synced to the cloud. That way, Azure AD can match your username and password hashes with all these breached lists and tell you if there's a user that is compromised. Now, once you have enabled password hash sync, the next thing is, how do you remediate these accounts automatically? So for that, let me switch over to my PC.
Yep.
Cool. So Azure AD offers you a user risk policy, which can automatically force secure password change on a user. So I'm in identity protection again. I'm looking at the user risk policy. I can assign users and groups, just like I showed earlier. The key thing here is defining the risk level for your policy. So here I can pick between high, medium, low for user risk. Our recommendation for customers is medium and above, and that's the policy we use on the consumer side as well. Once you have defined the risk level for your organization, the next thing you do is the response. So here you define the control. It could be either password change or it could be block. We recommend you to use password change. But then we know there are organizations that can't master their passwords in the cloud. For those, you can go with the block policy. So I simply configure the password change policy here and hit on enforce and save. So the next thing I want to do is see how I'm impacting my users with this policy. So I switched over to the users flag for risk section. And here I see Alex's account is at high risk. Let me dig deeper here. So what I'm seeing here is that Alex had Tor browser activity. And the other cool thing is he had a user with leaked credentials. So Alex probably signed up for Ashley Medicine with his corporate account. Maybe, I don't know.
We did not rehearse that.
He signed up for a third-party website that got breached, and now his credentials are leaked. And let's see what happens to his account when he tries to sign in.
All right. So, as you can see, my account's been marked as being leaked. That comes either because of our IP attack detection or because we saw a list that actually got to us from the wild and went through our credential processing system. Either way, or it could also be because other behaviors, which we can get into later. But in any event, the system has become confident that my password is in the hands of bad actors, right? So what we're going to do is see what happens when that happens, and we turn on the policy. So logging in with my compromised account. All right. We get this error message, right? And I'm going to try to make it big for you. Okay, it just says your account's at risk. And to help you get it back into your account, we're going to need to verify your identity. Isn't it cool that we set up multi-factor auth? All right, so I have an authenticator app set up. And All right. So we'll just approve it. Again, it's super easy to use. Way, way better than punching in codes. Okay, and then the next thing is, hey, let's update your password. So the bad guy is gonna be required to know your existing password and have control of your second factor, right? And then, but the good guy in this situation is the first mover, which is what we're looking for, right? So as soon as we detect this problem, we're locking down the account. The very next login, that user has to do multi-factor auth and pick a new password, which is running through our dynamic band password system, which makes it strong. Right, so we're moving to a nice place. It's not being reused elsewhere, and it's not guessable, right? So these are, this is the next kind of major policy we wanted to show you there. All right, we're moving on, going fishing. Oh, let me bring you back. Hey, all right, so next category, phishing. We had 3.2 million risk events in August that went out. And what we would look at these as is basically places where the login behavior was anomalous. Phishing is an interesting problem, right? Because when I send you a mail that looks semi-convincing, curiosity kicks in, right? I have had people call me and say, I got this mail, I'm kind of suspicious of it, should I click? And I'll say, no, you shouldn't click. And then they'll say, but what if I already did? Mom?
Why are you asking?
So this actually happens regularly. So here's the thing, like your organization, the users in your organization by our metrics are gonna click 15% of the time. 15% of users will click through, not just click on the link, but actually punch in their username and password as a result. 15%. Now, what if I do the whole thing? I put up posters in the elevator and posters in the break room and like send out the email to tell people not to get phished. Then you know what the number goes to? 15%. It has zero measurable effect. Sorry, but the posters look good. All right, so at the end of the day, phishing is a problem also because I can gather so much information from the phish, right? Once I click through, I can get the kind of browser you use, I can get the IP address you're coming from, there's a bunch of information I can gather. The phishers don't have to work very hard, right? So when I was building this deck, originally I got this mail sent to me from a friend saying, hey, should I click on this? And no, what if I already did? And if you look at the URL here on the from address, it's aspect film and video. Like, doesn't sound much like Office 365 or Azure AD, and yet 15%, okay? Lots of urgency in these mails. There's standard tricks that they use to say you better act now or you're gonna be in trouble. If you click through on that link, this is the thing you saw. You probably got malware when you clicked through as well. We'll talk about that. Maybe somebody else can talk about that one. And so now I've got your username and password. Now, this one was a pretty clumsy attempt, but all of your users would be fooled. Even though the URL is wrong, right? Even if we turn the whole border red and tell you not to click it, you're gonna click through, right? Google does an interstitial and it's like, stop, don't do this is unsafe. And I'm so curious, right? And you just can't stop yourself, right? So you click through and you punch in your username and password. So in that situation, we bring to bear our anomaly detection stuff, right? And I touched on this a little bit earlier. Everybody's gonna be like really cool cocktail party machine learning expert at the end of this next 2 minutes. Basically, a machine learning system uses there's supervised and unsupervised. Ours is, the one that we use is supervised. And all that means is that we have data that we can train the system on. When we make a guess, there's something we can look at to find out if we were right or we were wrong. So if we like challenge you with multi-factor auth, and then you pass the challenge, and then your behavior stays completely normal, then we know we were wrong to challenge you, right? If we fail to challenge you, and then your behavior goes haywire and you start sending spam and like laundering credit cards, we probably should have challenged you, right? So what we do is we look at about 100 different elements of the login, and those things are all built into a piece of code, a binary that runs on our login servers, and scores every single login by basically taking the memory of how that user has acted in the past, the memory of how their tenant behaves, intersecting that with the current login, looking for the drift, right? And then we can score the various elements of drift against the probability that that login is gonna be a bad login, that it will have gone to a bad guy. And those probabilities, run from essentially 0 to 100%. And then we can take action if you have set a policy. We can take action, right, on that risk factor and then decide, should we challenge or not challenge? In our consumer world, we do this, all day long. And every single one of those challenges is kind of remembered for a couple of weeks. And the data that we look at is, what does Skype tell us about fraud in Skype? What does Exchange tell us about fraud in Exchange? What does the user tell us? Like, help, I've been hacked, or did I change my password? There's a lot of things that we can look at. The most important element is user behavior drift. So if you suddenly start logging in from, I don't know, pick a place, I was going to try to be nicer. No, let's pick something new. Let's say like West Kansas. Okay, so sorry if you're from West Kansas. If you're from West Kansas, man, we start logging in from West Kansas all of a sudden. I promise you, if I start logging in from West Kansas, something is wrong, right? I live in Seattle. I've been to West Kansas, love it, but the thing is that you have to look at like the behavior of that user and how is it drifting. And if that user behavior is drifting over time, we have a behavior analysis algorithms that will tell us, okay, we messed up, right? Now we can't tell that in the moment, but over time we can tell. And then we can use that, the system can use that to retrain. We process about 40 terabytes of training data a day. And what happens is the learner, which is the other component here, the learner goes through that data and then looks at, okay, we predicted this, we got that, what do we need to tune? And then we build a new binary, we push it out to all of our login servers, and we start over, right? Day over day over day over day. And the system self-trains. Hint, it's not machine learning if the machine isn't learning, right? Clever algorithms are not the same as machine learning. Machine learning means the system self-trains. So we have a self-training system. It's one of the largest, if not the largest of its type in the world. And it scores, like I say, 14 billion logins a day. So that gives us the ability to detect the anomaly, right? So somebody gets phished, we can catch the use of those creds. We can catch first use of those creds, right? And then we can challenge on first use. And once again, Nitika's going to show you how.
So Azure AD can detect anomalous behavior. So every time we see some user signing in from a new location, new IP address, new device, or we look at close to 100 data points, we can flag that and then we can take action on it. So what you're looking at is the sign-in risk policy. Looks very much like the user risk policy and the MFA policy we looked at earlier. So here I can define the users. I can then define the risk of the sign-in. So here I have the choice between low, medium, high. Again, our recommendation is medium and above. Go with that. That's what we do on the consumer side as well. So once you have decided the risk level of the sign-in, the next thing is the access controls that you want to require. So here you have two options. One is requiring multi-factor authentication, or the second one is to block the sign-in. Now, again, we recommend multi-factor authentication. That helps with the user productivity, reduces your help desk call, because every block will lead to a call that the user will make to the help desk. So simply assign the users to the policy, pick the risk level, medium and above, very simple, define the control, require multi-factor authentication, and hit save. Now we have saved the policy, and now Alex will show us what happens to the end user once the policy kicks in. All right, we're back. So here, we're in a slightly unique and different situation. My browser has changed. Anybody recognize the browser? Anybody know it? The Onion? Tor, right. So this is a Tor browser. I am a huge, as a lot of security guys are, I'm a huge advocate for privacy. However, there have been some studies that were done last November that indicate that 94% of logins to enterprise environments from Tor browsers are malicious, right? So, hey man, we just call it like we see it. Right, so Tor browser login is likely to trip our risky sign-in stuff. So what we're doing here is we're just going to try to log in. Okay, and then, I'm the bad guy, and I know you don't believe it, but somehow they guessed my password. Hopefully you understand deeply now how they get the passwords, right? All right, so I'm going to go ahead and sign in. Oh, I got to do it again. I knew it had to happen at least once. All right, great. And so once again, I'll try to blow this up for you. Come on, stretch. Oh, not that much. Ooh, okay, I feel like I'm in Wayne's World all of a sudden. All right, so suspicious activity detected. We've detected something unusual about this sign-in, right? We're not going to tell the bad guy exactly, like, sorry, you're on a Tor browser. We can't let you do, we don't give information at this point, right? For obvious reasons, right? We don't want to tell the bad guy what to do differently, but we do give kind of a friendly message to the user, and then we say, okay, we need to verify your identity. Now, everybody's expecting you to switch back to my phone now, right? But I'm not going to switch back to my phone because I'm the bad guy. I don't have the phone, right? So I don't have the second factor, so I've basically just defanged this attack. I've just stopped it with a sign-in risk policy.
Really easy to do. Again, a couple of clicks over here. Now, I love my team and the work we do, and I think we're awesome. I'll be blunt about it. I think we do great work. But we're not perfect. And every algorithm, even the machine learning system, has false negatives, right? So bad guys can punch their way through at some small number. There are certain accounts in your world that you should not allow any possibility of login. Your global admin, your exchange admin, your CFO, right? Now, I know the C-level guys in your organizations complain, I don't want the friction, but you got to do it, right? Because don't leave your most important users the most vulnerable, okay? And so what we're going to do is just to show you real quick a little bit of extra juice here. One of the things we announced at this conference is that we're able to actually support third-party multi-factor auth solutions. So if you have something cool and fancy you want to do, you can do something cool and fancy. Nitika's going to show you how to set it up, and then I'll demo the usability of it.
Perfect. So Alex talked about how there are some accounts that you can't take any risk with. Machine learning is great, but it's not perfect. So when it comes to administrative accounts, you want to make sure those are locked down with multi-factor authentication. So what you're looking at is the conditional access experience, and here I've created an MFA policy for my administrators. I'll quickly walk you guys through the policy. So what I've done here is that I've manually included all my administrative accounts in this policy. So I've included myself, who's the admin on this tenant, as well as Alex, who's also an admin. Next, I've chosen all the cloud applications. As I mentioned, you don't want to take any risk with these accounts, so you want to MFA them for all access. So simply pick all cloud applications here. Don't try to optimize. And then the conditions. Since I want this policy to kick in all the time, I haven't picked any conditions. But you can see how you can fine-tune the policies for your end users based on sign-in risk, location, device platform, client application, time, and whatnot. Now moving on to the access controls that kick in. Here I've simply required multi-factor authentication for my admins. This is using Azure multi-factor authentication, but as Alex mentioned, you can get fancy. You can require third-party multi-factor authentication like Duo, RSA, Trusona, and we'll show you some of that. So I simply picked Azure MFA here, just enable the policy. It's already enabled, hit on save. And with that, Alex will show us what the end user experience looks like.
All right. All right, so we're back. Usually when I do demos, I demo out of this account, Alex at Wingtip Toys. And because I demo a lot of admin functionality, I demo it as an admin. So Nitika has set up a policy that says, look, if you're an admin, you've got a multi-factor auth every single time. I am a huge fan of this policy. I'm begging you, put multi-factor auth on your admin accounts. The time my team spends on dealing with tenants who've been compromised and their admin accounts have gone down, they're like, oh yeah, it was password 123, and I didn't have MFA. Like, like there's a recent, I'm not going to pick on anybody, but there's a recent breach in the news right now, and if you go read the article, they'll say, oh yeah, simple password, no MFA.
Yeah.
Right? It just happened, major player, one of our customers, bomber, right? And it's just not necessary. So turn on MFA for your admins. It's not hard. Okay. You feel nagged yet? I'm sorry. I get emotional. All right, so we're going to go and use my normal demo account. And this account is set up, again, multi-factor auth always because I'm an admin. All right. Okay. And once again, I'm getting a sign-in approval request. And somebody's blowing up my phone. Okay, by now you guys know what this looks like, right? It pops up on my phone, I say approve, and I'm signed in. So, I have got, yay, my admin is MFA protected, and it was so much work. Now, things to know. If I hadn't flushed my cookies, I wouldn't be doing this right now, right? Because you can remember the machine. You don't have to do multi-factor auth on the same machine over and over again. The machine can become a factor, right? So this is not actually super high friction. The idea here is we're creating friction for the bad guy, and generally you'll only see this on a new machine, right? So multi-factor auth you can make choices, but it doesn't have to be every time. Let's go ahead and drill in real quick and go take a look at our mail. And in the mail, we're going to see that there's a mail from the system which is actually a Protection Weekly Digest. You are getting these mails. I promise you, if you're a customer of ours, you're getting the mail. Please check into them because you'll see things like, oh look, 10 risk events or 8 compromised users. If I drill into this, the second part of the policy is gonna kick in, right? So the second thing that Nitika did, she said is, if I'm going to the Azure portal, then I'm gonna get this enhanced authentication, right? And in this case, we're just gonna take advantage of an opportunity to show off some cool stuff that a partner, Trusona, has done that we can show you in the system. So we're gonna go ahead and click into risk events. And we have a new challenge. And this is a place where, whatever multi-factor auth you're using or want to use, you can do that. So we're gonna bring up the Trusona app. Okay? And you can see it was saying, Wingtip Toys Online is asking, are you who you say you are? I'm gonna say I accept this login. And then to me, this is the cool part. It says, well, show me your driver's license. Prove to me you are who you say you are, right? So we're looking forward to a lot of really cool innovation in the credentialing space, because it's not passwords, right? Death to passwords. And so what happened there is I just showed my ID. Hi guys, how you doing? I just showed my ID, and the Trusona application scanned that identification, was satisfied with that, and they have all kinds of cool tech to make sure that it's not like a photocopy, all right? And then I got logged in. So I got to add a second factor saying, look, the actual Azure portal is super important. Now with conditional access, you could further restrict that and say, you can only get into the Azure portal if you're on CorpNet, or only if you're on a compliant device. So conditional access is, the complete package, right? I'm just showing you certain elements of it, but this is a cool example of where we've had some partners that have stepped up and done some really cool things that we can add in. So once I'm in here, I can go in and start investigating the security events. Now, Nitika talked to you about that before. Something I want to add on to this is that if you are not into yet another dashboard, we could have like another hashtag yet another dashboard, to go look at for risk events or things like that, then you can programmatically access all of this data. So all of the security information that we're generating for you about your tenant is programmatically accessible. And to just kind of prove that, what we've done is actually, what Michael has done, is built a Splunk app for this data. So what you're seeing now is the same exact information that's in the dashboard in Splunk. Just because it's programmatically accessible. We can put it in Power BI, we can put it whatever. We use, at Microsoft, we use ArcSight for this, and like it's in our stuff there, and we signal and we generate tickets based on this data. So you don't have to have a thing where you're like, oh, I gotta navigate to the browser every day. So we really highly recommend whatever is your mainstream system, your process, wire into that process so you're getting the benefit of this signal. So when a user's account is compromised, you're not sitting around on your hands, right? Okay, so. Cool. Back to our slide deck. All right, I'm going to reference an old movie now. All right. Here is where this talk came from. A buddy of mine in our Get to Production team named Mark Morozinski was like, I need to get a talk on security stuff and what we as GTP should be asking our customers to do. And that's kind of what was the genesis of this talk. And I had this slide, I was like, if we could just get people to turn on some of these basic features. The stuff that we've shown you here, none of this was hard, right? It was like, check this box, go find this thing. You can review this video and you'll know what to do. If you do these things, you will effectively stop any of these attacks from working against your organization, right? I mean, we do the responses. We are, if there's a big news article about some scary hack to some government or some big company, my team is probably having a rough day, right? Because we're helping those guys deal with it, with the high profile stuff. And what we find out again and again and again is it starts out the exact same way. I password sprayed that guy and got one account. With the one account, I got in and I downloaded the gal. Now that I had the gal, I phished everybody in the gal and password sprayed everybody in the gal. Now I have 250 accounts in that organization. Right? Now I look through the org charts and I figure out who I want. And I figure out the relationships of the people I've already got to the person I want. And I start working my way towards them. And when I get close enough to them, right, I take over. Or better yet, I found an Exchange admin. Awesome. Now I can do act on behalf. Right? Now I can delegate permissions. Or, oh, better yet, you didn't MFA your global admin. I own you. Now, I'm safe on-prem, right? Except for those same passwords work on your VPN, and I punch right in there and I start doing pass the hash, right? And now I'm moving up and I'm your domain admin on-prem as well, And then I get to sit undetected for 140 days and do what? Nothing good, right? So if you do these things, you're going to make traction. If you look at the number of things we detect versus the number of things that we could detect, a lot of that has got to do with configuration. I'm going to give you some startling numbers. We've got to get 16% of tenants overall doing password hash sync. That means 84% of those dudes are not finding out when we see their credentials in the wild. We could tell you, you got to be listening, right? So we need the password hash sync turned on. The true leak numbers are therefore much worse than what we're seeing, right? Password Spray took down 45,000 accounts in August, none of which had to go down if they were using our password mastering, right? So password write-back would prevent a lot of those attacks because we can intercept the bad passwords and make them spray-proof. And then the risk events, this is a really scary one. We detected 3.2 million risk events. We challenged 6.4 thousand of them because that's all the ones that had policy that allowed us to do the challenge. The rest of them we just reported on. Think about that. Essentially, of the 3.2 million risk events, 3.2 million of them went through, right? I mean, you subtract 6,000 from 3.2 million, you get 3.2 million, right? So please, you know, we've given you the playbook here, right? This is a step-by-step instruction guide, how to protect your organization. My investigations team is exhausted. If you guys could help us out by turning on some of these policies, it'd be awesome, okay? And the worst one for me is this one. And this number is like, I made the guy who did one of my data scientists, I made him pull this number like twice, because I just didn't believe it. And then I challenged him, I went down to his office, I was like, and he showed me, and it's true. 0.73, not 73, not 7.3, 0.73% of tenant admins are MFA protected. 0.73%. Like, come on, guys. You know, we can do better, right? So this is my my request, is let's try to do better together. Here's the summary of the things that we need you to go do. This is a takeaway slide, so you can go home and, you know, remember what you saw. You know, the big ones are password write-back, password hash sync, risk policies, user risk policies, and look at the reports. So 5 things, right? And they're all summarized there. All right, I want to talk very briefly about, again, I'm like the Debbie Downer of Microsoft. Like, I'm never the guy with the good news. So guess what? You're going to do all this stuff, you could still have a leaked account. So if that happens, you want to make sure that that account is not a privileged account. So your job is, in this case, go take a look at privileged identity management. And the idea here is to have just enough access and just-in-time access as something that you can run in the system. And the basic idea is, like, if I want to be an admin, I have to go through a workflow, which might be multi-factor auth or manager approval or whatever. I go do my task, and then 30 minutes later, my admin rights have expired. So it's a very powerful model for making sure that we minimize exposure that we have to assume. All right. There's 2 more talks that are going to be awesome. We have just scratched the surface of what conditional access can do. It's a really cool and powerful toolkit, kind of a Swiss Army knife for regulating how access is done in your organization. Caleb, who's on my team, and Chris Green, who until very recently was on the Intune team, will be co-presenting that tomorrow at 10:45. I'd highly recommend that talk. And then my friends Joe Dadzi and Mark Wall will be presenting privileged identity management and the access review features right next door, like right there, tomorrow at 12:30. So I'd suggest you do the first talk, grab a coffee, maybe like a muffin, come over here, do the second talk, and check it out. All right. With that, I have one more thing I have to show, which is, hey, cool. All right. We'd love your evals, love to hear how we did. And we are bang on time for questions. So with that, thank you very much for your time and attention. Go turn on the features. And then we'll take questions up here.
Hey, Alex. It's always great to see, and it's great to see those really hairy figures. It's just fun and scary at the same time. Couple questions. Self-service password reset with password write-back is great, but as you know better than anybody else, we've spent 17 years training users to do Control-Alt-Delete and change their passwords on premises for Active Directory.
Right.
Any plans for a password filter with banned passwords?
Yeah, so well, there's two different things, right? And so one we have to look at is, can I do password reset from my desktop and have it actually go through the cloud? And that is actually, I think, already shipped, and there's one bug I know about in it, but it's basically there. So by the time you go back and look it up, you know, or I send you an email, like we can do that already. Okay. So that's for password reset. And because you're going to turn off your expiration policies, right? You're going to turn off your expiration policies. That's how passwords will change in your organization. You're not going to see it, like, people do not spontaneously change their passwords. They do it through password reset. But we are also working on a filter so that all password changes on-prem can be checked against the banned password list. And that is something that Michael's working on in conjunction with the ADFS and AD Connect Health team. Okay, great. So that's months out. But.
Okay, the second question is, any plans for support for the full Unicode character set? You know, like, spaces, for example, or anything like that, like NIST is recommending?
I don't know of anything on our current backlog to do that. And I don't, the person who absolutely owns that is not in the room. I will tell you how I think about it, though, is that the right way to approach this problem is to get rid of passwords. And so rather than making it slightly harder, I mean, like, you get phished with Unicode, you're still getting phished. Yeah. Right? You get breach replay with Unicode, you're still getting breach replay. So really, a relatively small fraction of overall stuff is from weak passwords. So I think our energy and our effort is going to what we call NOPA, with the no password move, which is, and we're working on that right now and hard. So, hopefully by this time next year, I'll be showing you the 10 different ways you can sign in with no password in the equation at all.
It'll be a moot point, right?
Right, and I think probably I'd rather put the energy there, but I don't know for sure the answer to your question.
Okay, thank you.
Okay.
I've had some customers ask, the initial MFA registration, what if the bad guy is the person doing that registration? Have you guys seen that at all?
Okay, let me tell you that in the wild, we don't see it. Like, what I'm saying is, like, hypothetically, it's a good concern. And then in practice, statistically, it doesn't happen. That said, there's a couple things that we do. Right now, when we do registration, we actually do a risk analysis, and we will not present the registration interrupt if there is any risk present. Any risk present. So that's a thing that we already do. Now, we've had customers who I think justifiably say, no, I want more. I want to know that I'm on a compliant device, or I want to know that I'm, on-prem. And so with that in mind, we're doing some other work that we hope to land early next calendar, which will allow you to set an arbitrary CA policy against the registration experience. So you can say whatever you want for registration. You can say, look, for you to register requires that you're, in this location on a compliant device, and it's Tuesday, right? And so that'll all be within the next 6 months or so.
Okay, terrific. Thank you.
Yes, hi there. Lovely session. So right now the password policy in Azure AD will force me to use between 8 and 16 characters, if I remember correctly, right? Do you know if that 16 character limitation will be increased? Because personally I use KeyPass, so I would like to be able to generate a highly complex 128 character password and just use it.
Right, that one I know. So Microsoft account on the consumer side, we've already done that. We've already expanded that limitation. On the enterprise side, I don't know where that sits in the backlog. I know it's in the backlog. So I could get in touch with you with a kind of an ETA on that. It's something that we're working on but haven't done yet. Right. And then I could also, if you'd like to have a beer later, we can have an argument about the cryptography and why it doesn't matter if it's more than 16 characters.
Okay. Well, all right.
I mean, if you have the compute power to break our hash, at 16 characters, then you're doing pretty good. But it is something that we're sensitive to and that we're working on.
Okay, and I also second the things that was said earlier about different character set. I'm from Sweden, and we have these 3 extra characters, and we are really struggling to be able to.
See, that's a good reason, yeah.
Yeah.
That's a usability argument, right?
Yeah, so that would really give us the ability, because we have a lot of calls coming in, and we have to change their passwords to something that doesn't contain our 3 characters. Right. And that shouldn't really be necessary, I think. Yeah. So
yeah, we'll take that feedback back,
yes,
for sure.
Thank you.
How does turning on these features impact applications that rely on Active Directory, like Outlook app on a desktop, a iPhone native mail app, Android native mail app, that type of thing?
Yeah, in virtually all cases now, we're dealing with modern auth clients, and they can do the interrupt. And so my advice to you is, if somebody is just you know, got like a POP3 client from an ancient thing, just have them upgrade it. I mean, I think that we have, you know, you can do app passwords, but I hate app passwords. They're terrible usability.
Yeah, that's what I had to do on my own stuff.
I think at the end of the day, from a usability and security perspective, get on an OAuth client, you know. And I know that sounds draconian, but I think that one of the things that I think we have to, I'm a blunt person, you know, one of the things we have to be willing to do is to say to our customers, like, no, you don't get to use that like 3-generation old phone that doesn't, like Apple at this point is doing OAuth, you know, Google is driving OAuth. Everybody's got OAuth clients at this point. They're available, you just got to pick them up. And so I don't know of too many places where you can't get that. If you absolutely cannot do modern auth on a client, then you get into things like be very restrictive about who, I think you end up ultimately losing the MFA aspect of it. And so you need to get super restrictive about who gets to use that app and from where. Right? And so then you start thinking about things like time of day, IP location, you know, device compliance and all that kind of stuff and try to restrict it on that element.
Yeah, because we actually, I turned this feature on for myself in the, you know, older, you know, probably 3 or 4 months ago. But even with Office 2016 on, you know, I'm not sure if it was 100% patched on a PC desktop, one of my 2 Macs and my iPhone all required app passwords.
Yeah, so I'd be interested if you want to shoot me an email. We can talk through kind of where we're at with that now. But yeah, we as professionals in the industry and as, you know, us and as like the vendors, you know, Apple and such, we're all trying to push people to a modern auth stance.
Okay, thank you.
Can you take some questions from the back mics, please?
Oh, I'm sorry. I didn't see back mics. I really apologize.
Hi.
Hi. Hey, back there.
Could I follow up on that topic, please? You would still block the legacy authentication where you see the risk, but the user wouldn't get a convenient...
Yeah, we can do that, and what we really want you to do is just turn off legacy auth. From the back?
Okay.
So we use Azure MFA. We have it turned on right now. Our security team brought up a concern with the authentication through the app. Because you can authenticate from the lock screen, at least on iOS and potentially Android, they feel that a stolen phone scenario now the hacker can authenticate to that MFA without being able to unlock the phone.
Sure.
There's other third-party authenticators who do require you to unlock the phone, even though you can say approve from the lock screen. Is that something that you're looking at as well?
Yeah, so I guess I'll answer in theory and then I'll give you the answer you probably want. The answer in theory is, hey, that's a device, that's a possession proof, and it's still a possession proof if it's unlocked. And so the idea is password and, right? It's not a 2-factor, it's a 1-factor at that point. That said, we hear you and we've heard other people. And so the main thing we're working on right now is adding PIN mode to all factors. Yeah. And so we're making it possible for if you're getting an SMS or you're getting a voice call or whatever through Azure MFA, you can get a PIN that goes along with that and then work it from that perspective.
Thanks.
I'm sorry. Okay, here's one in the back.
So my question revolves around your phishing example. We're currently federated with Microsoft.
Sure.
And we had to modify our WI agent, user agent list because we had so much pushback from our users when we started migrating to 365 and they actually had to authenticate because they had logged on their machine and they felt they were losing SSO. So right now, our users' expectation is that when they hit 365, that we pass to organization WIA through Chrome or IE or Edge or whatever, and then go straight into their mailbox. They would flip out if they had to be presented with their password, at least from one network. So my question is, from the phishing example, if they received a message and clicked it, if the hacker had created some sort of website that was allowed or tried to do the WIA pass-through because of their browser, what information could be taken? I mean, it's not a password, right? It's just like this user is authenticated and goes through, or what information?
Yeah, the token should be secure. If the token was generated for a relying party, there's a key that protects the token. But what I'm going to tell you, so from that perspective, not much.
Okay.
In fact, I don't want to say absolutely not anything because I haven't, like I'm sure some researcher somewhere could argue with me. But there's no known threats to the token security in that sense. But I will also say that a good phishing campaign is not going to ask you to go to something you're used to not having a password. They're going to take you to DocuSign, a fake DocuSign page or something else that you've never seen it before. So you're like, oh, I guess it needs a password, and you just punch it in.
Okay, thanks.
Yeah, so I think we're going to rotate back to the front.
Okay.
So we'll just go around in circles here. So,
how many of the features are lost if you're federated? So if you're federated and the user's obviously sent, we use ping identity.
Actually, shockingly few. With federation, especially with ADFS, the token we're getting from ADFS.
So particularly with non-ADFS federation, we federate with ping identity.
Yeah, so with ping, I think the story is mostly the same. In most cases, the federation token is going to carry a bunch of information about how the login was done at the federation server. And then in addition, remember that the person that presents the token to us is the client.
Yep.
Right? So we do have a direct interaction with that client. And so when we have the question of where is my client, you might have said one thing to the federation server, something different to us, but at the end of the day, that request comes from a place and we can see the place. We know the time of day that we're being presented with the token. We know, there's still a lot. We can see the machine information, the browser information. So we lose anything interactive, right, with the login. So when you do our logins, there's actually some JavaScript running to like kind of track your behavior on the login screen. And there's some other telemetry we're picking up with our JavaScript if it's an interactive login. But interactive logins are actually pretty rare if you think about like your clients that have the cached creds and all that kind of stuff. Yep. And of course the bad guys don't like them. They don't use the interactive method. They go to non-interactive because they know that we can't get telemetry. So it's not actually very lossy at all. The main issues here are getting back to you can do things that make it worse. Like you can say, oh, all my users are required to VPN all the time, which of course makes them all have the same IP address, and then that's harder. But generally speaking, it doesn't really impact us much.
So if we were to add the conditional access for a risky sign-in of medium to high requiring MFA, we've potentially already MFA'd the user at ping identity depending on their network location.
And the token would carry that information. The token we get from ping carries the information. Yeah, we'd know. Okay. We'd know it was MFA'd. Yeah.
Okay, cool.
How you doing?
Hey.
Thank you. I'm in the security identity space.
Awesome.
And loving, Azure and Office 365. We've been making our shift to the cloud. My question is surrounding some of the features for conditional access and risk-based access. Our challenge is a lot of these features is not that we don't want to turn them on. It's just that these come with the premium level. Mm-hmm. And so is there any talk about providing some of those services? Because it's not that we don't want to turn these things on, it's just that it's very costly, and our shift to the cloud has already been kind of expensive.
Right. I'm going to disclose something here, and I will say that you're into a point of vigorous debate, even within the team. What we are working on and hope to get done early next year is what we're calling baseline protection.
Okay.
And it's going to be essentially the same kind of thing you get on Microsoft account, which is, it's in fact designed to be the Microsoft account level of protection. Okay. And what that is we're going to pick the factors you can use, and we're going to pick the registration policy, and we're going to protect the level of protection and where you get it, and you're not going to get much information about what the risks that we saw were.
Okay.
So it's a sophistication model. We're going to protect everybody, but if you want to get deep and like start plugging into your SIEM, start plugging in custom MFA solutions, anything like that, then those are going to all take money. And all of that said, in the grand scheme of things, this isn't that much money. When you look at the $19 million cost of a breach,
Understood.
we do have lots of discussions about how we can do it and make it, because there is that side effect tax. I'm not actually kidding that we have on the team that we spend a lot of energy taking care of people who've been hacked. I'm going to do one more lap and then we're going to wrap up so the next speaker can set up, and then we'll take questions up here. So.
In our environment, we have a majority of our users already behind the Azure MFA. But we're currently forced into this hybrid scenario where we also federate with ADFS because we have a small set of users that need hard tokens. Is there any plan to support something like a Gemalto token so that we can move to total cloud?
Yeah, okay, so I'm going to go kind of fast on your answer, but one thing you saw was what we just showed in conditional access, where I'm pointing over here to where the Trusona folks were. I think they moved on. But what essentially is, right now we're working with Duo, RSA, and Trisona, but there's many other vendors coming along. So you talk about, YubiKey or whatever, and we'll bring those guys on board. Anybody who wants to play can play. Then also we're doing Oath standard support, Oath hardware token standard support that we expect to have done by the end of this calendar, in preview for a few customers and then publicly, next year. And that will allow you to take any Oath compliant token and use it. And that would not require like a separate license fee from another vendor or anything. And so you can just use what you have. And we actually already have that in our MFA server product that runs on-prem, which we're actively trying to get rid of. And so we're bringing that feature over as a part of that migration. So pin mode, anything that you can do on the on-prem stuff, we're trying to bring across so that we can turn off the on-prem sales. Because on-prem is not as good as cloud. But yeah, we're going to be doing Oath token support early next year, and we support other vendors for hardware tokens now, right? So like Duo has a hardware token, RSA has a hardware token, and you can do them right now.
Excellent, thank you.
Thanks. All right, we are at 10 seconds, and as a presenter, I know it's tough to be not allowed to set up. So what I'm going to do is we'll just take questions down here. If you guys don't mind the remainder of you. I don't smell that bad. I showered this week, I promise. So like, just come on down. And thank you so much for your time.